Hey folks, sorry I'm not there today. Wasn't planned. I have an activity we're going to do anyway with a short lesson that I'm going to go over right now, which involves exponent review. Knowing your rules on exponents can help you tremendously as we move forward. And there's just a couple pieces we want to look at. I won't take long to describe them, but I'll show you the keys. And then the activity you're going to work on today in class. And if you don't finish it in class, you can finish it at home tonight. It'll be due tomorrow. And you don't have to get them all right. We're going to go over them to make sure you know the exponent rules we need to be able to follow to continue on. Okay, so the first rule is the basic rule that when we are multiplying exponents, we're going to add those exponents together. And we're putting them to the power, we're going to multiply them together. So this is the original statement right here will be when I multiply them, I'm going to multiply the constants first. So I'm going to get 28 out front. Now, there's no number on the y's, but I know the 1 is there. So it's going to be times y to the second, because I'm going to add those exponents together. And then x to the third times x to the seventh is going to be x to the 10th. Also, by the way, if I make a mistake in the video, let me know. Counts as $1. Okay, so we're on to the next one. This time it's a function to an exponent, meaning we're going to distribute that exponent to every number in there. I'm not going to figure out what 2 to the 7th is. I'm going to write it down as 2 to the 7th. That's just fine. X to the 21st, so I'm putting it to that power, and y to the 28th. So that's the basic rule for when we're multiplying. Now let's take a look at dividing. Okay, so whenever I'm involved in quotients, I'd like to cancel things on the top with things on the bottom. You can work this however you want, but this is the big key for me. I always remember that in the United States, some things are happy when they're in the cold. If they're in the cold, then they're sad when they're in the warm. And if they are happy in the warm, then they are sad in the cold. What does that mean? It just means before I cancel anything, I can move any exponents. If it's positive up top, I can move it down below and become negative. If it's negative down below, I can move it up and make it positive. So what I'm going to do with this equation is turn everything into a positive function. I'm going to leave the x to the 5th up top. I'm going to bring this y to the negative 6th down below. I'm going to put a dot just so I slash them out so I know what I'm doing. It's going to become y to the 6th on the bottom. The z to the negative 7th is going to become z to the 7th on the bottom. X to the 3rd is already positive. I'm going to leave it down there. Y to the negative 5th, I'm going to move up as y to the 5th. Z to the 3rd, I'm going to leave down below as z to the 3rd. And q to the negative 5th, I'm going to move up as q to the 5th. You've noticed now I've made all the exponents positive. This tends to happen on the problems a bunch. And now I can cancel things as I go. This x to the 5th and x to the 3rd cancel. 3 of them are gone. It's like a little war there. And I get x squared left on top. I've got a y to the 5th and a y to the 6th. That means the y's are going to... 5 of those are going to cancel. We left with y on the top. I've got a q to the 5th, nothing else anywhere. I'm going to leave the q to the 5th on the top. I've got a z to the 7th on the bottom and a z to the 3rd on the bottom. That's going to become z to the 10th. Often problems ask for all positive exponents, so that's the technique I'm going to do each time. I'm going to take my original statement, going to convert everything so it's a positive exponent, and then I'm going to cancel the tops and bottoms. Do you have to use my method? No, you do not, but it works pretty well. Okay, let's take a look at one other thing that has to do with fractional exponents. I'm not going to talk too much about that. I'm going to let you try it in the assignment. Let's switch to it over here. Okay, the easiest thing with exponents is when we're multiplying. So if I'm distributing this 3 to the m and to the x, I'm going to end up with m to the 3rd, and then x to the, just stepping off to the side for a second, 2/5 times, I'll write it as a fraction, 3 over 1. Multiplying is easy. We just multiply away. So it becomes 6 over 5. You can leave it as that fraction right there. You don't have to convert it back. Okay, so that's that. Now when we add them, though, it's a little more annoying. Let's take a look at that. Okay, whenever we're multiplying variables with exponents, we have to add those. So this is going to become n to the 1/4 plus 1/8. You got to remember that when we're dealing with exponents and we're adding them, we have to have a common base in order to add. So what I'm going to do is I'm going to multiply 2 to top and bottom there. because that's the same as multiplying by 1. It doesn't change the answer. N to the 2 over 8 plus 1 over 8, which equals n to the 3/8. So you guys get the common denominator when you're adding the exponents together. Last thing to know is that anything to the 0th power, 7 to the 0th, x to the 0th, 3 to the 0th, anything to the 0th power equals 1. And you don't have to just accept that from me, that it's actually the case. I'll prove it to you right now, and I'll show you why. Let's go x to the 0th power is the same as x to the 5th times x to the negative 5th. And why is that? Because 5 minus 5 equals x to the 0th. I can rewrite this, and you don't have to worry about this if you don't want to. If you just want to accept it's true, it's good. I'm going to rewrite this. Think of it as this fraction right here. I'm going to write this as x to the 5th over, I'm going to take this one, move it to the bottom, over x to the 5th. And if we simplify that, these are the same. Therefore, the answer is 1. That's why anything to the 0th power is 1. Okay, good luck on the questions. I'll check in on you and see how you guys are doing. Good luck.